Our topics today are quartiles, box plots, and weighted averages. And these first two absolutely have a relationship between them. And that's kind of where we're going to start. What quartiles do is they cut the data set into 4 equal parts. That kind of probably should make sense to you in the idea that there are 4 quarts in 1 gallon. There are 4 quarters in $1. So the idea that the prefix QUART kind of points us towards something with 4 involved is true. And so when we're talking about quartiles, we're cutting about ways to cut the data set into 4 equal parts. If I was gonna cut something into 4 equal parts, let's say I had, I don't know, loaf of bread or candy bar or something. If I was gonna cut that into 4 equal parts, I don't think I'd start left to right and try to figure out where 4 equal parts would go. Instead, I'd be much more likely to cut it in half first and then cut it in half again. And that's exactly how we're going to approach this. One of the things that we know already is the median cuts the data set in half. So our median goes right here and cuts the data set in half. And then from there, if I want to cut this into 4 equal parts, I'm just going to do that again. Over here on the left-hand side, I'm going to cut that half in half. And what that thing right there is that is the lower quartile. It is the median of the lower half of the data. That's our lower quartile. And basically, if we want to cut this into 4 equal parts, we use the median to cut it in half. We'll cut the lower half of the data in half. That's our lower quartile. And then we can cut the upper half of the data in half, and that's going to be our upper quartile. That's going to be the median of the upper half. So that's our upper quartile. One of the things I want to make sure I mention is that the lower quartile can also be referred to as the first quartile. And if you think about that, we're going left to right. This is the first quartile we get to. And then also the upper quartile can be referred to as the third quartile, because that would be the third quartile that we get to. And sort of you can see in our picture over there that the median then could be called the second quartile. It would be really unusual to do that. Typically, we just call it the median. But the words lower quartile and first quartile are interchangeable. They mean the exact same thing as each other. The words upper quartile and third quartile are interchangeable. They mean the same thing as each other. That's how we're going to cut our data into 4 equal parts. Any question about that terminology or any of those words? Next, we're going to look at actually doing it with the data set. So we'll put some concrete examples on here instead of just talking about it in the abstract. Okay. One of the things we're going to use the quartiles for is to find something that's called the 5-number summary of a data set. And what the 5-number summary is made up of is the lowest data point, the lower quartile, the median, the upper quartile, and the highest data point. Those 5 numbers give us a summary of the data set. They essentially cut it into 4 equal parts for us. So what we're looking for here when we're looking for a 5-number summary is we're looking for the lowest, the lower quartile, the median, the upper quartile, and the highest. Those are the 5 numbers we're looking for when we're after a 5-number summary. If it's our job to find the 5-number summary for this data set right here, our initial first reaction needs to be, hey, I'm going to find the median at some point, so I better write these from lowest to highest. So here we go. And we'll be a little careful here. Let's see, I have a 2, a 3, 4, 5, 7. Check my work here. Make sure I don't miss any. 8, 11, 13, and 15. Then as I go through here, I can see my data set's made up of 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. I'm going to make sure I have 9 numbers when I wrote them from least to greatest. 1, 2, 3, 4, 5, 6, 7, 8, 9. That doesn't guarantee that I wrote the numbers down correctly, but at least I have the correct number of numbers. So there's a pretty good chance I've written them down correctly. Okay. We want to find the 5-number summary. The highest and lowest, those come really easily. When I want to find the highest, it's just the 15. The lowest is just the 2. So those are really easy to get. I'm going to give you a second to find the median of this data set. I know you know how to do it because I know how good those quiz scores were, but somebody tell me what the median is. Lorraine, Zutzel, Genesis, Emily, awesome. Thank you for firing that off. We've got 7, and the idea here is we have 9 data points, and this is a little bit of review just in case anybody is a little uncertain about the median. That's an odd number, so we will have one right in the middle, and then there'll be 8 other data points, and of those 8 other data points, half of them, 4, will be lower than the median, half of them, 4, will be higher than the median. So when I want to go find the median here, I need to count up 1, 2, 3, 4 and section that off, count down 1, 2, 3, 4 and section that off, and sure enough, the median is this 7 right here in the middle. So I have 3 of the 5 of my 5-number summary. Here's a really important part about the 5-number summary. The median is not in either half. Of the data set. Let me go ahead and put that. The reason that this is really important for us is when I go to find the lower quartile, what I'm looking for when I find the lower quartile is the median of the lower half of the data set. That's what I'm looking for, the median of the lower half of the data set. It's important to note the lower half of the data set is just this part right here. It does not include the 7. And then similarly, when we go to find the upper quartile, we are looking for the median of the upper half. It's important to note the upper half are these numbers right here, and it does not include the median. So we don't want to include the median in either half of the data. All right, so finding the lower quartile here, the lower quartile is the median of the lower half. In the lower half, I have 4 data points, which means, and since that's an even number, I won't have one right in the middle. There'll be 2 below and 2 above. So as I section that off, I've got 2 below, 2 above, and my median would be here. Remember, to do that, we'll find the 2 numbers closest to the middle and find the mean of those. There's a lot of terminology here. The mean of these 2 numbers will be the median of the lower half, which will be the lower quartile of my data set. I'm going to say that again, and you let me know if any of those words don't line up for you. The mean of these 2 numbers will be the median of the lower half, which will be the lower quartile of my data set. Okay, 3 and 4 are the 2 that are closest to the middle. You might say, well, I've done a bunch of these. Halfway between 3 and 4 is 3.5. And you'd be right. But just to sort of write this down for anybody who wants to add them up and divide by 2, that's 7 divided by 2, that's 3.5. Sure enough, the median of the lower half, which is the lower quartile of the data set, is 3.5. Just like when we found the median of an entire data set, it's okay if our lower quartile is not one of the data points. And here it's not, and that's just fine. We're going to use the same process to find the upper quartile. I may be a little less explicit. You let me know if you see something that doesn't make sense. The upper quartile is going to be the median of the upper half of the data set. There are 4 data points. There's not one in the middle, so I'll go 2 and 2. And then halfway between 11 and 13 would be 12. And so the upper quartile is 12. And so our 5-number summary for this data set has a lowest value of 2, a lower quartile of 3.5, median of 7, upper quartile of 12, and the highest value is 15. Let me know if you have any questions on that before I have you try one. Okay, great. Here goes. Find the 5-number summary for that data set. I'm going to make a poll for this, and the poll is just going to ask you for the lower quartile and the upper quartile, because I'm pretty confident you can find the highest and the lowest, and you won't be able to find those quartiles unless you find the median correctly. All right, so find the 5-number summary, and then the poll is the lower quartile followed by the upper quartile. We'll go another 40 seconds on this and then talk through it. Find the 5-number summary, definitely the kind of question you could expect on a homework, on a quiz, on an exam. All right, let's see where we are on this one. Okay, not unanimous, but strong agreement. Some 15 and a half, 23 and a halfs on there. We'll have to keep our eye out for that. And oops. You let me know if you see anything in this explanation that you're not sure about. Okay, here it goes. Because we're looking for the 5-number summary, we're looking for the lowest, the lower quartile, the median, the upper quartile, and the highest. Those are the 5 numbers we need to find. Before we do anything, though, we want to write these from least to greatest. And let's see, that's 11, 14, 17. 11, 14, 17, 21, 26, 27. So if you didn't write them from least to greatest first, things would definitely go sideways in a hurry. Remember, anytime we're looking for a median, we're going to want things to be least to greatest. And then that's also going to be true if we're looking for the upper and lower quartiles. We definitely want them arranged from least to greatest. Looking at this data set, we have 6 data points. That's an even number, so I'm not going to have one right in the middle. Half of the data points, 3 of them, will be lower than the median. Half of the data points, 3 of them, will be higher than the median. And so when I go section this off, I've got these 3 that are lower, these 3 that are upper. The median's going to be in between those 2. And so I'm going to find the mean of these 2 numbers, and that's going to be the median of my data set. Okay, a couple ways you could do that. One way is to say, what's halfway between 17 and 21? That may or may not be comfortable for you. If it's not, it's totally fine. 17 plus 21 over 2 is 38 over 2, and that's 19. So our median of this data set is going to be 19. We didn't do the upper and lower yet. We can go ahead and knock those out. Those are easy to find. The lowest is 11, and the highest is 27. Okay, now we have to find the 2 quartiles. These are the things we were actually asked for in the question. And when I find the lower quartile, what I'm looking for is the median of the lower half. Lower half of the data set is right here. Yes, the 17 was part of how we found the median, but remember, the median is in here in between. So that 17 is part of the lower half. If you weren't sure about that, now you can be. Even though we use the 17 and 21 to find the median is in between those. And so the 17 is a part of the lower half. Okay, well, in the lower half, I have 3 data points. The one in the middle is the median of those. And so the lower quartile for this data set is 14. We're going to use the same process on the upper half. The upper half of my data set is right here, has 3 data points. There is one in the middle. It's the 26. And so the upper quartile for this data set is 26. There's the 5-number summary for this data set. Let me know if you have any questions about finding the 5-number summary, what the quartiles are, before we move forward into talking about box plots. Okay, terrific. Box plot is a shorthand name for what's more formally known as a box and whisker plot. It's something that we can draw when we want to see, we want to use the 5-number summary to draw a picture of a data set. The box and whisker plot, or box plot, is how we'll do that. To start out with, I'm sort of going to make myself a number line down here. I look at my data set, I see it goes from 2 to 15. So when I draw this is basically just a number line. Think of it as graph paper. It's basically a guide for me. I'm going to go from 0 up to 20. And that's just so I have a place to put my box plot. Halfway between there would be 10. I could do a 5 over here and a 15 over here just to sort of help me draw it. That's what this is for. This is just a guide to help me draw it. It's called a box and whisker plot. And the box, part of the box and whisker plot, goes from the lower quartile to the upper quartile. That's where the box is going to go. We don't have to be perfect. So I'm going to find 3.5 over here and put a line there. And I'm going to find 12 and put a line there. And I'm going to make a rectangle. And that is the box in my box and whisker plot. You can see that the median is going to be in between those two somewhere. We're going to go ahead and put a mark in for the median. Here it's going to be at 7. And you might think that's a lot closer to 6. Can't you do better than that? Yeah, maybe I can do a little better than that. And maybe I'll make it actually straight. There we go. But when we're sketching a box plot for our purposes, it doesn't have to be perfect. to be honest, I'm going to be more interested in you reading a box plot than I am you creating a box plot. But if you know how to make one, then I feel pretty good that you know how to read one. Okay, what about the rest? Well, the rest is the whiskers. We've taken care of the box. Now we're going to do the whiskers. So we can see the lowest number in our data set is 2. So I put a mark there, and I'm going to draw a whisker that goes over to that 2. And my highest number is 15. I'm going to draw a line that goes over to that whisker. And so now I've made my box and whisker plot. And just to sort of let you see how this thing works, we have our lowest number, our lower quartile, our median, our upper quartile, and our highest number. And so that's how we drew this box plot. Now, what's really important to remember when reading a box plot is the whole point of these quartiles. What do the quartiles do again? Somebody remind me. What do they do? And it's not the easiest thing to type, but somebody let me know. What do those quartiles do anyway? How do they cut the data? We draw 5 lines, that's true, Edison, but what Lorraine and Stephanie and Nicole have said is perfect. They cut the data into 4 equal parts. They do, Natalie. If we were going to talk about percentiles, which we will briefly touch on percentiles, the 25, 50, 75, and 100 is definitely a part of that. So I'll bring that up again when we talk percentiles, and that'll just be very brief for us, but you're exactly right. So when I look at this data set, what my brain wants to tell me is there must be a whole lot more data points in here than there are in this little bitty whisker over here. But that's not true. This data is cut into 4 equal parts. 1/4 of the data is there, 1/4 of the data is here, 1/4 of the data is here, and 1/4 of the data is here. If you're thinking, how can that be? This is a big giant box, and this is just a little bitty line. How can they have the same number of data points? It's a really good question. Well, the reason they have the same number of data points is all this shows us is the data points here must be smashed really close together, and the data points in here are a little more spaced out. But what we know is there are the same number of data points in each piece because quartiles cut the data set into 4 equal parts. Visually, we don't want to accept that, but we know that it's true. And all it's saying is these are smashed close together, these are spread further apart. I'm going to ask you some questions about box plots and see how we're doing with the concept in general. Here's the first of those questions. Hours of battery life was recorded using data from 250 batteries. So 250 batteries were studied. We figured out how long they lasted, with 10 hours being the shortest battery life and 25 hours being the longest battery life. And I have a poll question for you here that I'm going to ask about this box plot. Did more batteries last less than 16 hours or more than 24 hours? It'll probably take me longer to type this than it will for you to answer. Just hang on. Bear with me. All right, so there's our question. Did more batteries last less than 16 or more than 24? We'll go another 15 seconds and then talk about this one. Let's see these results. This is always a fun one for me because I kind of know how it's going to go. Okay, we're kind of all over the place. Less than 16, the most popular answer here on this one. Most of the time, when I set up a poll for y'all to do, I'm expecting and hoping that everybody gets it right. This is the first time we've had a poll where I kind of know how it's going to go and it's not going to be great, and that's okay. Let's talk about what quartiles do again. Quartiles cut the data into 4 equal parts. And that means that 1/4 of my data points are here, 1/4 of my data points are here, 1/4 of my data points are here, and even though it's just this tiny little sliver, 1/4 of my data points are here. And so that being the case, what happens here is even though our brain wants to say, well, there's got to be a lot more data points in that huge thing right there than there is in this little bitty line over here, because we know what quartiles do, that's not the case. There are the exact same number of data points here as there are here. 1/4 of the batteries lasted less than 16 hours. 1/4 of the batteries lasted more than 24 hours. There are the same number of data points in each, and it's because we know that the quartiles cut the data into 4 equal parts. 25% of my data is here, 25% of my data is here, 25% of my data is here, and even though it's just a tiny little piece, 25% of my data is there. If you're thinking, how can that be? Well, what it tells us is that there are a whole lot of data points in here that are very close together. And there are just a handful of data points here that are spread out. And that's how there can be the same number of data points here as there are over here. I hope that helps clear this up. If not, if you're still not sure, you just let me know. That's one that I kind of know going in that it's going to be a little shaky, but hopefully we've cleared that up with this discussion. If not, you can tell me. And you know, we can kind of address Natalie's comment here too. If you look at this, 25% of the data is here below the first quartile. And then if we extend that further up to the median, half of the data is below the median. And then if we extend that up to the third quartile, we've got 75% of the data is to the left of there. And then if we extend it all the way up to the highest number, then we have 100% of the data. That's exactly what Natalie was referencing, and she's exactly right. Okay, let's try a couple more. Hours of battery life was recorded using data from 250 batteries. My question to you is, what percent lasted less than 24 hours? So this one is asking what percent of the batteries that were studied lasted less than 24 hours? We'll go another 20 seconds on this and then talk through it. See how we did on this one? All right, almost unanimous, really strong agreement here. It could be that I talked about Natalie's suggestion one slide too early, but that's okay. What percent lasted less than 24 hours? Well, we know that the quartiles cut this into 25% of the data is here, 25% of the data is here, 25 is here, and 25 is here. And if we want to know what percent of the batteries, what percent of the data points are less than 24 hours, we need to identify where 24 hours is. And then less than that would be everything that's over here. We add those up, and 75% of the data, 75% of the batteries lasted less than 24 hours. The key with reading a box plot is, even though your brain wants to tell you that this one and this one can't have the same number of data points in it, they do. They're just more spread out over here so that each one of these pieces has 25% of the data in it. Let's try one more, and it's a little bit of a contrast to the one we just did. The question we just did said, what percent lasted less than 24 hours? This next question says, how many? And so the idea that we had 250 batteries in this study is really important here. So now we're not after an answer that is a percent. Instead, we're after an answer that is how many batteries. And how many batteries lasted between 16 and 24 hours? I'll set up a poll for that one. We'll go another 30 seconds and then talk about this one. All right, let's see where we are on this one. Okay, split a little bit. The second most common answer is 50, and I know why that happened, so we'll make sure we talk about that. Okay, so question said, how many batteries lasted between 16 and 24 hours? So we find 16 and we find 24. Because this is a box plot, we know 25% of the data is here and 25% of the data is here. And so between 16 and 24 hours, that is 50% of the data. If the question had said what percent lasted between 16 and 24 hours, 50 would be correct here. But it didn't. It didn't say what percent. It said how many. And so what we need to find is 50% of the 250 batteries that were in the study, because it's actually how many batteries, not the percentage that we're supposed to respond with. And you may remember percent problems, you may not, but if we want to find 50% of 250, what we're going to do here is we're going to convert 50% to a decimal, which would be 0.5 or 0.50. Those are both the same. So that's converting 50% to a decimal. Of is a keyword that tells us to multiply 250. And so we're going to have 0.5 times 250 or 125. How many of the batteries lasted between 16 and 24 hours? 125 of them did. Half of them that were in the study. Let me know if you have any questions about that before we briefly talk about percentiles. One thing I will say is anytime you're taking a quiz or an exam, you want to kind of look back at the end and make sure you answer the question that's being asked. If you're asked what percent, then your answer is find the percentage by looking at the graph and you're all done. If it's how many, that's different. Now we're going to use that percent to figure out what percent of the total, and then the percent of the total will tell us how many batteries lasted between them. All right, percentiles. Percentiles come up sometimes, especially for teachers in the area of standardized tests. What percentiles do is they give the relative position of a data point within a data set. Let's use some concrete examples to help that out a little bit. The median we know is halfway through the data set. The median is above 50% of the data points. And that means the median is the 50th percentile. The 50th percentile means it is above 50% of the data points. Same idea is if you have a student in your class that scores at the 88th percentile, what that means is that that score is above 88% of the values that are in the data set. It doesn't mean they got 88% of the questions correct. It just means compared to everybody else, their relative position. If they're at the 88th percentile, then their score is higher than 88% of all of the other scores. We have no idea what their actual score was. Percentile just tells us how they did compared to everybody else. Percentile tells us where a data point is relative to all the other data points in the data set. With that in mind, we could say that the upper quartile here is at the 75th percentile because 75% of the data are lower than the upper quartile. That's really all we're going to talk as far as percentiles goes. We're not going to really do problems that involve percentiles. I just wanted to understand what they are so that down the road, if you get a bunch of information back and you find out that a student is at the 88th percentile, then that means they did better than 88% of the people who took that assessment, which is pretty fantastic. Okay. Quartiles, box plots, percentiles. Now we're going to shift our attention over to weighted averages. The idea behind weighted averages is that something in there counts more than everything else. Up to now, when we've been calculating the mean of a data set, everything is counted the same. Every data point had a weight of 1. We counted it 1 time. That's it. An example of weighted averages is grade point average. It's a perfect place for us to look at weighted averages is using grade point averages. And the idea here is this. We'll see it when we finish our calculation. But this particular student is taking a 5-credit math class, a 1-credit science class, and a 3-credit history class. The idea behind the weighted average is that this 5-credit class is going to count a lot. This 1-credit class is not going to count that much because they don't carry as much weight. Your first instinct here might be to say, well, they have an A, a B, and a C. If they have an A, a B, and a C, then they have a B average. What's the computation? Who cares? This seems really simple. That would be true if they were each worth the same amount of credits, but they're not. Since they're not worth the same amount of credits, there's a process we go through to calculate grade point average. The formula, if you want to call it that, that's used to find grade point average is the total number of grade points earned divided by the number of credits taken. So that's how we're going to find the GPA for this student. We have to figure out how many grade points they earned and then divide that by the number of credits that they're taking. Okay, so where do these grade points come from anyway? Well, you may be aware of this already, you may not, but you get a certain amount of grade points per credit based on the grade that you earn. So grade points per credit. If you have an A, you get 4 grade points per credit. If you have a B, you get 3 grade points per credit. If you get a C, you get 2 grade points per credit. A D is 1 and an F is 0. We don't have either of those in this problem. So we'll just look at A, B, and C for now. And so when we look at this student and we want to figure out how many grade points did they earn? Well, in that math class, they got an A. So this A means 4 grade points per credit. So for every credit they were taking, they earned 4 grade points. So let's see, 5 credits. Actually, let me do this. 5 credits, 4 grade points per credit. So 5 credits times 4 grade points per credit. They earn 20 grade points for that 5-credit math class. This is the same idea we're going to use for science and history. When we look at science, this student got a C in science, and a C is worth 2 grade points per credit. It was a 1-credit class, 2 grade points per credit, so we're going to multiply those. 1 times 2, they earn 2 grade points for that science class. Let me know if you see anything that doesn't make sense, you're not sure where it came from. In that history class, the student earned a B. A B is worth 3 grade points per credit. So 3 grade points per credit. It's a 3-credit class, 3 grade points per credit. So we'll multiply those and they earned 9 grade points for their history class. Okay. If I want to find the GPA, I need the number of grade points and the number of credits. So the number of grade points I can get by adding these up. 20 plus 2 plus 9, that's 31 is the number of grade points they earned. And we'll add up the number of credits, 5, 6, 7, 8, 9. So we have 31 grade points and we have 9 credits. So this student's GPA is going to be 31 divided by 9. And let's see. 31 divided by 9 is 3.44444444, and that keeps going. And let's see, I was told long time ago when I first read this, find the GPA to the nearest hundredth. So I'll find the hundredths place, 2 past the decimal. I'll look 1 space to the right. That number's 4 or lower, so we're going to round this down. And the GPA for this student is 3.44. It sure does, Lorraine. I agree. It sure does. One thing I want to mention here is this student has a 3.44 GPA. If we would have just said at the beginning, well, what difference does it make how many credits the classes are? I'm not even gonna take that into consideration. I just want to look right here at A, C, and B. And so they have a 4-point A, they have a 2-point C, and they have a 3-credit B divided by 3 classes. That's 4, 5, 6, 7, 8, 9 divided by 3. That would have been a 3.0. Well, that's no good. That's not how we calculate GPAs. And I also want you to notice, if all these were the same number of credits, it's true this student would have had a 3.0 GPA because they would have all had the same weight. But here, this 5-credit class carries more weight than the 1-credit class does. What happened here is this A brought their GPA up more than this 1-credit C brought it down. That's why they ended up with a GPA that was higher than 3.0, is because the power of that 5-credit A pulled it up to a 3.44. Do you have questions on this before I have you try one just like it? Okay, fantastic. And this is exactly how your GPA is calculated every semester and all your cumulative overall GPA. All right. Find the GPA for that student. And just to sort of make a note of it over here, an A is worth 4 points per credit, a B is worth 3 points per credit, a C is worth 2 points per credit. All right. Calculate the GPA for that student. I'll give you a little time on this because, there's quite a few steps to go through. We'll go another, I don't know, say 45 seconds and then do this one together. All right, let's see where we are on this one. All right, unanimous. That's fantastic. Very good. I'm going to work through it anyway, and there's something else I do want to mention before we finish up our discussion of GPAs. But since this went so well, I'll be relatively straightforward here. GPA is grade points divided by credits. And what we have here then is, let's see, this particular student had a B, which is 3 grade points per credit. So that's 5 times 3, that's 15 grade points. If you want to see that written, you know what, I'm not happy with that. I'm going to go ahead and write it out. Number of grade points earned is 5 credits times 3 points per credit. That's 15 grade points for that class. And then this C here is 2 grade points per credit. So 4 credits, 2 grade points per credit. So that's 4 times 2 is 8 grade points for that science class. And then finally, this A in history. This A is worth 4 points per credit, 2 credits, 4 points per credit. That's 2 times 4, that's 8 grade points for that history class. And then we'll add these together to get the total number of grade points. Let's see, 15 plus 8 plus 8 is 31. That's just coincidence that it was the same both times. It's not always 31, I promise. And then 5 and 4 is 9, 10, 11 credits. And so 31 grade points divided by 11 credits is 2.818181. Oops. And that keeps going. We were told to round to the nearest hundredth. So we will find the hundredths place. Look one space to the right. That's 5 or bigger. So we'll round this up to 2.82. And that was the unanimous answer, which is fantastic. That's really good. Couple of things I want to say. Remember, if we just pretended that these were all the same number of credits and didn't do a weighted average, a B, and a C would average out to a B 3.0. But we can see that this GPA is lower than 3.0. And the reason for that is because this 4 credit C pulled their grade down more than the 2 credit A pulled it up. The 4 credit class carries more weight, and that's what lowered their GPA. Great job on that one. One other thing I do want to say about GPA problems is this. Some of you may be even wondering it. Well, what about like an A minus or a B plus, for example? And that's an excellent question. What happens then is an A minus is worth 3.7 grade points per credit. A B plus is worth 3.3 grade points per credit. So instead of just 432 with those, if we introduce plus and minus grades, then we get a decimal part. The only thing that changes is, if this had been an A minus instead of an A, then they would get 3.7 grade points per credit for that A minus. And then we would multiply 2 times 3.7 to figure out how many grade points they earned for that class. So plus and minuses do play a role in grade point averages. We all know that, and that's how. Similarly, B minus would be 2.7, C plus would be 2.3, and that's how those factor in. Okay. This is going to feel really familiar when we work on it. When we read it, it's going to seem totally new and different. And then when we work on it, it's going to feel really familiar. Over the course of her first 3 semesters at college, Amy had taken 50 credits and earned a GPA of 2.35. She's taking 16 credits this semester. In order to bring her overall GPA up to 2.5, what GPA will she need this semester? That's a lot to digest at first, but just to sort of recap here for a minute, what's being told here is this. Amy's taken 50 credits and has a GPA of 2.35. And she would like to finish this semester with a 2.5 GPA. It might not sound very familiar yet, but you remember last week we did these problems where Carl has taken 7 exams and he has 1 more exam to go. What grade does he need to get to where he wants to get to? This is very much like that. So far, what we know about Amy is that she's taken 50 credits and she has a GPA of 2.35. Just a little reminder here that when we find GPA, that's grade points divided by credits. And so far for Amy, we know what her GPA is. We know her GPA is 2.35. And that equals her grade points. We know she's taken 50 credits. What we don't know is how many grade points she has so far. Very similar to the formula for the mean, because a grade point average it's a grade point average. It's the mean of the grade points you've earned. So it looks very much like a formula for the mean problem. And I don't know how many grade points she's earned so far, but because I know 2 of these 3 pieces, I can figure it out. So the number of grade points she's earned so far, let's see, I can multiply by 50 on the right so that those cancel, multiply by 50 on the left, and let's see, 2.35 times 50, Amy so far has earned 117.5 grade points. What we're going to do now is, how many grade points does she need? Because she wants to have this 2.5. So how many grade points is she going to need? And I hope this looks exactly like the 1 more exam to take, because for her, this is 1 more semester of school. Where is she now? What does she need to get to? Okay, let's see. So she needs a 2.5 GPA. And we don't know how many grade points that is. Here's a question for you that I don't think is an easy one, but I'm confident you can do it. How many credits is she going to have after this semester ends? What number is going to go underneath that division bar? She is taking 16 this semester, but altogether, 66. Perfect, Lorraine, Natalie, Genesis. Altogether, she's going to have 66 because she wants her GPA overall to be 2.5, not just for that 1 semester. She wants her overall GPA to be 2.5, so we need her total number of credits. We'll multiply both sides by 66 because on the right-hand side, these will cancel, leaving us with just grade points. And on the left, in order to have a 2.5 GPA after 66 credits, she's going to have 165 grade points. So in this 1 semester, what she's going to have to do is go from 117.5 to 165. She's going to have to bridge that gap. The number of grade points she's going to need this semester is 165 minus 117.5, or 47.5. That's how many grade points she's going to need this semester. Keep in mind what we were asked for here is what GPA will she need this semester. So we're not quite done yet. What we know now is how many grade points she has to earn. And so again, we lean back into this formula. The GPA that she's going to need this semester is going to be those 47.5 grade points she needs divided by the 16 credits she's taking, which is, I'm going to round it to the nearest hundredth, 2.97. So in order to pull her GPA up to a 2.5 overall, she's going to need a 2.97 this semester. Very much like we did with, we've got one more exam to take. What score do we need? This is, in order to pull that 2.35 GPA up, how is she going to need to do this semester? She's going to need a 2.97. So this is another example of a weighted average, because what's going on here is these 50 credits carry a lot more weight than the 16 credits she's taken this one semester. So in order to move her GPA just a little bit, she's going to need a really good GPA this semester. Let me know if you have questions on that before we look at one more type of weighted average. Okay, fantastic. One more to go. This one involves calculating a grade. In Lacey's math class, homework counts for 25% of her grade, quizzes count for 30%, and exams count for 45%. If her scores are what we see there, what is her overall percentage in the class? What's her overall grade? So what we're going to do is we are going to take these scores that she has on homeworks, quizzes, and exams, combine that with the percent that each of those things count towards her overall grade to figure out what her overall grade would be. First thing we're going to do is figure out her mean score for each of these. And so homework, we have 100 plus 80 plus 0 plus 85, and we're going to divide that by 4. Be careful here. There's a little bit of instinct to not count that 0 as one of the scores and divide by 3. Don't do that. It's one of the scores. She has a 0, so we count it as one of the scores. So 100 plus 80 plus 0 plus 85 divided by 4, because she has 4 scores. And when we do that, 100 plus 80 plus 0 plus 85, we have 265 total points divided by 4. Her mean homework score is 66.25. And that would be a percentage. Looks like these are all out of 100. But 66.25 is her homework grade. Then we do the same thing with quizzes. And with quizzes here, we have 90 plus 72 plus 90 over 3. If you see any numbers that you're not sure where they came from or they don't make sense, you let me know. Here we have 90 plus 72 plus 90, which is 252 divided by 3. 84 is her mean quiz score. And then she only had one exam, so we don't really need to do any work to find the mean for that. Okay, so at this point, what we've got is we have her mean homework score, her mean quiz score, and her mean exam score. If they were all 33% of her grade, we just add them up and divide by 3, but they're not. This is a weighted average, and we have to take those weights into consideration. We're told that homework counts for 25% of her grade. So when we go to calculate her grade here, we're going to take that 25% and turn it into a decimal, 0.25, and multiply it by her percent, her mean score for homework. We'll add that to the same thing for the others. We want quizzes to count 30%. So quizzes are 30%. So we're going to do 30% written as a decimal multiplied by her quiz mean score. And then finally, we're going to do the exact same thing for the exams. Exams count for 45%. And so we're going to do 45% written as a decimal multiplied by her mean exam score. Now all we have to do is simplify this and we'll have her grade. The key here is to make sure you attach the appropriate percentage with each category. Make sure that you have 25% with the homework mean, 30% with the quiz mean, and 45% with the exam mean. To simplify this, we just have to do order of operations. We're going to do our multiplication first, and then we'll add afterwards. So first, we're going to multiply here, and we'll have, let's see, 0.25 times 66.25 is 16.5625. I'm going to keep all my decimals till the very end. That way my grade will be as accurate as possible. We won't do any rounding till we get to the very end. And I should have put where to round in this question. I apologize for not doing that. When we get to the end, we're going to round to the nearest 100. Okay, and then let's see. 30.3 times 84 is 25.2. Then finally, 0.45 times 85 is 38.25. We'll add all those together. And end up with 80.0125. And I should have said it at the beginning, but we're rounded to the nearest hundredth. So we will find the hundredth place, look one space to the right, that's 4 lower. So Lacey's overall grade is 80.01. Exams count for the most significant portion. They carry the most weight. Quizzes are next, and homework is the least. And if you look at that, you can kind of see that 85, 84, and 66, well, she still ended up with a pretty good grade here. That homework didn't pull her down that much because it was only 25% of her overall grade. So because it carried the least weight, it didn't have a tremendous negative impact.